Welcome to my channel Abrar Electrical World. This is a video about the CT connections for differential protection of power transformer. The same will also be applicable to the busbar protection, but we will discuss that in a separate video because there are some other details when we discuss the busbar protection. Now this is specifically for the busbar protection for the differential protection of the power transformer. So let's see what is there in the diagram. I have drawn the diagrams myself on the whiteboard and then took the picture here. Now see, this is diagram number 1, in which I have shown here that these are the two CTs. This is the power transformer. These are the here two buses, generators. I have shown just to show you the flow of the current during the fault. Now see, if there is a neutral here, what happens? This neutral is when I call it towards the object side. Toward the object side. The CT is toward the object side. Now see, if there is a fault outside of the zone, this is outside of the transformer, then I have shown you the direction of the current. Current will flow from right here and will flow like this through the transformer and then into the fault, and then this is the return path of the fault current. Now see, when you have the primary current like this, the secondary current will be in the other direction, and similarly here the direction of the primary current is from left to right, so direction here will be from S2 to S1. Now if you look at this direction of the current, you see this current is flowing like this, returning to the neutral, and the other current is flowing from S2 to S1, then here into the relay, and then it is going back right here. Now see, the two currents here are in different direction. This is going up, and from the right hand side it is going down here. This is something wrong here, or the color is wrong, but the direction is right like this. You see, this is the returning here. See, just look at my cursor and then you will understand. Here what is happening? The current is like this. See? So in the relay coil, the current is in the opposite directions. That is the difference of the current of both the sides. This is down, this is up. So the pickup current will become 0 and differential protection will correctly not operate because the fault is external to the transformer, and the differential relay is designed to look into the fault inside its zone or the specific object for which it is designed. Now this is a specific object is power transformer here. Now let's go to the second slide. What happens when the fault is internal? See here. Now I have shown the fault here, and I have added a generator here just to show you the direction of the current. So if the direction of the current is from both the sides like this, what will happen? From the left hand side, the current into the fault will flow and return from this blue line here. See? Similarly, this generator here may be the far end, but will feed the fault like this, and then this will return like this. I am talking about the primary. See? Primary current. Primary current in your network, the high voltage current. See? Now what happens here? When the current direction is like this, here the current direction in the secondary CT will be from S2 to S1 because it is from here P1 to P2. So it will be S2 to S1, and then it will come here and then return through the CT relay coil and will go back into the CT secondary. Similarly, what will happen here? Now the direction is like this, left to right. the current in the secondary will be from right to left, from S1 to S2, and then it will come here, here, and it will go again into the relay coil and then return to the CT neutral. Now see, here in this case, when the fault is inside the power transformer, the relay currents are in the same direction, so they will add up. Now the relay pickup current will become I1 plus I2. So therefore, the relay will pick up and immediately isolate the transformer in few milliseconds. Now, assuming if there is no current from here, then there is no problem. In the case of internal fault, only this current will flow. There will be no current from this side, and this current will be alone sufficient to trip the circuit breaker. It is not the difference of current. If there is no generation from here, no current from here, this will become zero, but still this current will be enough to pick up the relay because the settings are made like this. So I think I am able to make you understand that the philosophy of the connection of the neutrals of the current transformers. I have shown you one phase. Similarly, we can draw the diagrams for the other two phases as well. So I will explain those things in other video lectures, that what happens when there are uh, high value inrush current and high value through fault currents external. So I will make the different videos for them. Otherwise, you will be confused. So I hope you liked my uh, lecture, this lecture, and I'm sure that you have understood the basic concept that the neutral of the CT secondary should be made on object to be protected site for correct operation of differential relay. We will discuss pickup setting values in another video lecture. So if you like my lecture, my video, this one, so please like, share and subscribe our channel. The channel is for the voluntarily education and training of the our junior and senior electrical engineers, and for the sake of the copyrights, I draw the pictures myself and then take the photos and post them in my slides. So this is essential. When you make the slide, you have to be careful about the copyright.